students, already we have learned the definition of metal finishing, the technological importance, followed by techniques and followed by some principles. So in those, what you already known about of this metal finishing is coating of any metal, metal oxides or non-metals including of alloys or any polymers on the substrate on the article. In such process, modify the surface characteristic feature is metal finishing. So if not changing the surface characteristic feature, supposed to be after a few days it is removed from the surface, that is only the metal coating. So far metal finishing and metal coating is different because it is look like a permanent, that is temporary. So far in this metal finishings, not only the one advantages, number of advantages are there. Those are starting from chemical resistance to the optical resistance, they making the dyes, making electroplated inductions, including of electric dyes, followed by it is some other important techniques also. As the same way, so we can follow at the time of metal finishing, we have to follow some principles. Principles means theoretical explanation given to the any natural observation is a principles. In those, at least in any metal finishing, so we have followed three principles. Those are, number one is polarization of electrode, second one is decomposition potential, third one is we can call it as a over voltage. So in those, slow supply of electron, slow supply of ions to the surface of the metal is a polarization. The minimum potential required to continuous electrolysis, we can call it as decomposition potential. So more than that of the theoretical calculation, the over voltage is more applied, we can call it as a over voltage. Whether it is over voltage or increased decomposition potential, we won't get the electroplated metals. Instead of that, only coated metals we can get it, because of some other reasons are there. Later we will go into discuss. So in that, in the last class we have discussed regarding on electroplating of chromium. So already known of this definition of electroplating is the coating of metals or alloys on the substrate by electrolysis, we can call it as a electroplated induction or electroplating. So in this electroplating, so we can require of this plating band, required of current density, required of pH, so required of optimum requirement of temperature and throwing power. So before going to that, so all these things, already what you have learned, comparison of all these things we can require. So in that chromium plating at the time 0.1 or 0.2 volt is applied. So in that 0.1 or 0.2 volt is applied at the time, so it is nothing but indication of slow supply of electrons from the bath. Slow supply. If it is increasing this fast supply, immediately there is no polarization. Instead of this metal finishing or deposition, we can get it as temporary metal coating. So far, this require very minimum. So at least 0.1 volt or 0.2 volts of that much of electricity is enough to drift the ions from anode to the cathode for metal finishing. So this is current density is less. Second thing is that plating bath contains, first one is metal ion concentration, whether it is either 1 mole or 2 mole, or maximum you require is 3 mole, not more than that of the 3 moles. Based on their molecular weights, you can calculate and you can dissolve in 1 liter of DM water. After this metal ions concentration, it requires other electrolytes also, followed by complexing agents. Why do you want these other electrolytes? These other electrolytes increase the conductivity of the plating band. If you supply the very less electricity also, very neatly. The ions are occupied or placing of king site or favorite site or head site by only minimum using of less electricity because of increasing the conductivity of plating bar, that is again adding of that is other electrolytes, followed by complexing agent. This complexing agent, if you add it in that, at the time of metal finishing, it activates the surface of to be coated. It is activate the surface of a substrate you can add it. For example, coating of copper on the iron, at the time we can add the copper sulfate of 1 gram or 2 gram to this plating bath at the time. So the copper ions accept the electrons from the iron. The copper ion plus iron, it can become iron ions and copper you will get it. So at the time, increasing the surface activity, this activeness of the substrate by making it as ions by adding of this complexing agent and other organic additives. These are the requirement to this very neat finishing, smooth, even and strong, smooth, even, strong, bright coating or deposition of substrate. We require all these things. So in that you can compare with that also. As the same way, followed by its pH. pH is optimum. If the pH is very less, at the time of hydrogen ions is released at the cathode. So for optimum pH means 4 to 8 pH is you can prepare the plating bath. You test the pH is in between the 4 to the 8. Followed by temperature. Temperature is room temperature. Of course, this supposed to be it is releasing of heat energy. It should not cross the 45 degree. Should not cross the 45 degree. So in that manner you can maintain. As well as you can calculate the throwing power of the plating bath. What is this throwing power? Means ability of the plating bath to develop a deposition of uniform concentration, uniform metals on the substrate. The ability you can taking any size, you can taking any shape, you can taking anything also. You can calculate what is its size of or dimension of the articles or pre-treated metal. So afterwards you can decide the size of the plating bath and how much of this concentration of the electrolytes you can calculate it. Then you can dissolve in that bath. You can very neatly prepare with calculated amount of everything. You can calculate it and prepare the plating bath. That is, we can use it. The term is plating bath. So these are the conditions you have to be fulfilled. As the same way, is it holds good to the chromium plating on this? We can check one by one. So current density is less. Yes, we are using of 10% of efficiency, 0.1 volt or 0.2 volts is using for decorative purpose of using of the chromium we have applied, no problem. So metal ion concentration we are taking as 100 grams of chromic acid. So 100% of chromic acid very concentrated we have taken, and 100:1 concentrated H2SO polar you have taken. So afterwards, what are the other things we have added? We have not added to this because we have taken the concentrated acids. Its pH is beyond the range. It means below to the 4. It might be 1 or 1.5 because we have taken the concentrated acids. At the time, you are adding any other electrolytes, complexing agents, organic additives, supposed to be added to this calculatively prepared plating bath. Immediately they have reacted themselves. Instead of that plating bath, it is a look like a container of chemicals. So far, avoid to this what we have done. Because of these problems, we have not using the anode of chromium also. Instead of that, plumbium coated with arsenic or antimony or stainless steel we have used also. Because supposed to use it. Instead of chromium plating, we have taken the chromium chloride, chromium sulfate has taken, we are thinking of those things. but directly we have taken up this chromic acids, these are to be as changed. So far the pH is very less, temperature of course is optimum. If it is increased temperature, at the time of, instead of this metal finishing, coating has to be taken place, that is look like to be temporary. Temporary in terms means it is not bright, it is rough, and powdery types of coating has taken place because of we can get it as the particles, the ions, instead of favorite site occupied, instead of non-favorite site it has occupied. So at the time we should not get the very neat, smooth and hard coating has not taken place. So these things you have to keep it in the mind. So pre-treated metal has taken. So after pre-treated, so the container, that is the plating bed, will be selected and prepared. Then pre-treated these to be coated metal or article. Then you can fix to the cathode of the battery. Anode is also, of course, in this theoretical what is there, everything is you can prepare and start the switch on 0.1 volt or 0.2 volt enough for decorative purposes. If you want, you can converting into as heavy metals or using of compressor, using of inner pistons, valves, rings, any of inkjet heavy metals requirement softs at the time you can making it as a hard coating of chromium. So as this is so match with words with the electroplating of chromium, all these parts. So as the same way, so we can pass on to the electroless plating. So name itself indicates that is electroplating with electricity. So less means without electricity. The same definition is holds good. So we can apply to that. Coating of metals or metal ions from the metals, coating of metals or alloys from its ions. So on the catalytically active surface in the presence of reducing agent without using of electricity. So I think you got it. Without using, so we call it as a electroless. With using of electricity, we call it as a electroplating methods or electroplated inductions. So in this electroless, no electricity. So you have taken the reducing agent of selected. So those reducing agents are formaldehyde, hypophosphites, hydrazines, all those things you have taken. So in that, so metal ions act catalytically active surface. How you can do it? Later we will explain. So catalytically active surface is not there. It has not taken place of the coating of that is electroless plating has not taken place so far. So these procedures you have to followed. So in this electroless plating, you require the plating bath. So whether it is you coating on this article, plating bath, followed by this reducing agent, followed by complexing agent, followed by pH, that is buffer solutions. You can maintain the temperature, so as well as you can calculate the throwing power also, as well as ditto with of the electroplating, but without the electricity. So far, now we can going to explain the electroless plating of nickel. Electroless plating of nickel on the metals, on the metallites, or on the non-metals. So whichever, first we can taking into as a nickel coating on metals. In that you prepare the plating bath. First is a metal ion concentration, that is nickel chloride. 20 grams of nickel chloride you can weigh and dissolve in the 1 liter of DM water. Hypophosphite ions you can weigh 20 grams dissolved in 1 liter of DM water. Then complexing agent is a sodium succinate, you can weigh 15 grams and dissolved in 1 liter of DM water. Then buffer you can weigh the sodium acetate, weigh 10 grams and dissolved in 1 liter of DM water. So that much of big container, big container, big bucket. So any of the sizes you can taking into as we can adding of all these things. So keep it aside. So keep it aside. Then you can select the metal. So whether in that metal we can using as a pre-treated means you can first dip it into this H2SO4 pickling, followed by dip it into its degreasing, that is organic solvent, followed by you can dip it into this flux sodium or ammonium chloride, followed by taking it applying a mechanical removing of any sticked particles are there and subjected to the flame test also. Now we can using the term as a pre-treated. For this is what. For how it can increasing of this catalytically active surface you can make it. So then you can dip it into this stannous chloride solution. So afterwards taking back, dip it into the palladium chloride solution. At that time, so what you can already pre-treated metals are catalytically active surfaces has taken place. Then you can dip it into the already prepared plating bath of a nickel. So you can dip it immediately, whichever we have used that hypophosphate is taken as a reducing agent. In the presence of reducing agent, that is reaction takes place with water. So then it is a 2PO 2 minus is become a 2PO 3 minus plus 2 hydrogen H plus as and electron is separated. This electron separated, that energy is used to decomposition of nickel chloride into the nickel and chloride. So this nickel is start to be coating, start to be deposited from column wise or row wise, one point to another point to another point. It is look like of it is the king site. So become according to the calculation 20 to 30 second is enough for 1 centimeter square has to be plated. According to that, what is the size of it automatically plated, then is you will taking into as. So this is the coating electroless plating of nickel on the metals. So this is for using for decorative purposes also and hard purposes also. In these decorative purposes we can using of so it is a bright in nature. At any days also it is should not remove this nickel from, because it is the active surfaces is prepared, as well as the finally modified the surface characteristic picture. It is look like of permanent. So in these hard metals we can use it, make it hard also. At the time we are using of cylinders, pistons, any other axles, any hard metals you want it. At the time you can coating of in this manner, so you can using for evergreen. So this is coating of nickel on metals. As the same we have to follow for metallites also. For little bit is changing to the non-metals. What are the example of non-metals? Either you want to coating of the nickel on glass, or either you want to coating of on silicates, coating of nickel on plastics. At the time, don't touch of this degreasing and pickling, the flame test. Instead of that, you can directly dip it into the stannous chloride, followed by then dip it into the palladium chloride. At the time this is enough. It is pre-treated also, as well as this surface is catalytically active. When the surface is catalytically active, afterwards you prepared the plating bath of nickel chloride, you dip it into the pre-treated articles, whether it is plastic or glass or silicate, immediately. So this, as in that hypophosphate is release the electrons, that electron is decomposition of nickel chloride into the nickel. That nickel atoms are coating on the given article. This has to be taken place. So it is only for using of decorative purposes, not for any other purposes, because these are the non-metals not having impact strength like of the metals. So this is the example of electroless plating of nickel on the non-metals. So in the satisfy the definition is catalytically active surfaces we have prepared, followed by presence of reducing agent. So in that the catalytically active surfaces coated and this reducing agent become oxidized species. This is the example of electroless plating of nickel on metals and non-metal substrate. As the same way, we are going to continue electroless plating of copper. So electroless plating of copper on metals also, metalloids also, and non-metals also. In this, if you want to take it of metals, any of the metals you will take it. In that, first is degreasing, followed by then it is a pickling, followed by in the ammonium and that is flux, followed by you can apply to the flame test, mechanical eraser, everything you have done it. So afterwards, so same also for increasing this catalytical activity of the surface, you can dip it into the stannous chloride, followed by taken out and dipped into the palladium chloride. This is, we can call it as a pre-treated metal. So this pre-treated metal keep aside and you can prepare the plating for both this copper on the metals or non-metals. How do you prepare this plating bath? This plating bath is containing 12 grams of copper sulfate you weighed and dissolved in 1 liter of DM water. You can pour into the bath. Next is formaldehyde. You can weigh the 80 gram and dissolved in the 1 liter of DM water. You can pour into the plating bath. Followed by we can using of complexing agent is EDTA. And EDTA you can weigh 20 grams dissolved in 1 liter. You can pour into this copper sulfate bath containing. So followed by you can weigh 15 grams of sodium hydroxide and 14 grams of rachel acids. These are we are using as a buffers. So we have prepared these salts and reducing agents, buffer also, followed by complexing agents also. What is there? We can check the temperature, followed by check the pH also. In that nickel coating at the time, pH is 4.5 to 4.5. Temperature is because of this nickel chromium disuccionates, it release the heat. So temperature is up to the 90 degree also, no problem. In this electroless plating, supposed to increasing of the temperature also, no problem, because pre-treated metal is catalytically active surface is having. So far we can some range is there, we can use it. As the same way, the room temperature for copper sulfate is 125 to 30 degree is enough. Already pre-treated metal is dipped into the plating bath. Immediately the reducing agent is releasing the electrons, which is the reducing agent is formaldehyde, react with this sodium hydroxide OH, so releasing of formate as well as 2H2 plus 2 electrons are released. This is anodic reaction. That anodic reaction releasing electron is come and decomposition of copper sulfate into the copper. So first it has formed this copper 2 plus ion. This electron is going to add the copper metal. The copper atoms are coating on very neatly from either row wise or column wise. So at the time getting of king side, that is favorite side, very neatly according to the size of the pre-treated metal, it can coated. After half an hour or whatever the time has taken to be completely coated, you can taking and using as to our conveniences. Like this, electroless plating of copper on the metals, this has to be followed. As the same way, it is same for this for metallites also, but for non-metals don't you dip it into of this degreasing, pickling and flux. Directly you can dip it into this so what is we can call it as directly dip it into the palladium chloride and stannous chloride, or stannous chloride dipped, then followed by you dip it into the palladium chloride. So that makes the surface of nonmetals. Nonmetals includes of plastic, glasses, silicates, catalytically active surfaces we have prepared. Then what is the reducing agent is formaldehyde, releasing the electrons. That electron is dissociation of decomposition of copper sulfate to the copper. Ions become as copper. It is start to coating on based on the sizes, so that we can continue when it is completely coating of non-metals or plastics, glass, or even what we can call it as silicates. You can take out and use as suppose. So this is extended towards of PCB, printed circuit boards. We want only some clads, some line want to be making into as conductor. At the time we are taking the brush and you dip the brush into that, you draw one line. What is the sizes of the clad you prepared on these non-metals or glasses or plastics. So you draw it a line. So you dip the brush and we can coating look like of adding of stannous chloride on both the sides, look like of the line. Then it is you can applying of palladium chloride on that. So whatever this surface is applying of palladium and stannous chloride, that is you can dip it into this electroless plating of copper. So on that space only the electroless plating of copper is taken place. As the same way for this double-sided printed board, you taken out and make the grooves. So walls, this is also again you can apply this inner walls of that borer. You apply this stannous chloride and palladium chloride. Again you dip it into this copper sulfate plating, but automatically the inner wall is also coating. So this is what we can call it as electroless plated of copper on non-metals. Which is only using for convenience, decorative purposes. Either we can using inner side of some containers using for storing of water, or nowadays we can using of copper electroless plated copper coated containers using for storing the waters. So reaction of this copper, it is more raising of immunity for these human beings. So we have to use it wherever it is required. So we at least we can coating of copper, whether it is electroplated or electroless plated. So it is entire its life we can using as to same. This is electroplating and electroless plating. So the remaining topic is the difference between electroplating and electroless plating. So already you know about of this. You can better writing to me also in the exam. First is current density. Current density is very low in the electroplating. Electroless plating no current because it is electroless. Second thing is metal ion concentration is very low in current. So that is also, of course, it is little bit more. So then it is other electrolytes we have used in this electroplating. Other electrolytes we have not used. So this power electricity is we have used because of it drift the electron. That is the current we make it into as the surface of articles catalytically active by using of activeness of coated metals, activeness of base metal. So this is happened. So next point is other electrolytes, complexing agents. Complexing agents in both electroplating and electroless plating we have used. Followed by organic additives in the electroplating. There is no organic additives. We are using instead of that stabilizer and hartants. So this stabilizer becomes making into stabilize in this container, that is plating bath. Any of the anode and cathode themselves is avoid to reaction because of this adding of stabilizer and